Welcome to my project bazaar.com. Let me discuss about the project designing an efficient image encryption then compression system via prediction error clustering and random permutation. Let me discuss about the abstract of the project. Image encryption and compression has been implemented in practical scenarios. Here, pair of encryption then compression algorithm has been implemented and it will be performed efficiently. Here, encryption then compression system has been proposed with both lossless and lossy compression are performed. This approach provided a reasonably high level of security. Encryption turns your data into high entropy data, usually indistinguishable from a random stream. Compression relies on patterns in order to gain any size reduction. Here, encryption has been implemented by several methods such as gap, mapping process, clustering process, and permutation. In proposed approach, encryption then compression has been designed to receive an efficient image. First, segment the image into blocks. Each block gap, that is gradient adjusted prediction, is implemented gap scheme to achieve better speed and better prediction accuracy, and hence provide potential for further improvements in lossless image compression. Next, clustering algorithm has been proposed. Here, zigzag raster diagonal algorithm has been implemented. This ZZRD is a two-dimensional square matrix is split into exactly two halves diagonally, and the upper left part is scanned in zigzag fashion. Finally, permutation process is performed with key generation and encryption algorithm. At the compression part, modified flexible algorithm and length encoding process are proposed. For decomposition and decryption process performed by reversing the compression and encryption process. Finally, the decrypted image obtained from the decryption process, which should be represented the original information, then analyzes the performance based on the PSNR estimation. Let me discuss about the flow diagram for our process. First, capture the input image from the dataset folder. Select any one images from the dataset folder. Next, the images are segmented into blocks wise. So, image segmentation is the process of partitioning a digital image into multiple segments, that is set of pixels, also known as superpixels. The goal of segmentation is to simplify or change the representation of an image into something that is more meaningful and easier to analyze. Image segmentation is the set of segments that collectively cover the entire image or a set of contours extracted from the image. Each of the pixels in a region are similar with respect to some characteristics or computed property such as color, intensity, or texture. Adjacent regions are significantly different with respect to the same characteristics. Next, in the encrypted process, there are two algorithms proposed, that is gap, that is gradient adjusted prediction. Gradient adjusted prediction is an efficient prediction method for lossless compression of audio. By calculating its gradient in latitudinal and longitudinal orientation with a known context, the pixel value can well be estimated and used for predictive coding. However, when realizing this method in a real-time compression system, it needs a large amount of memory space. Number of operation for each pixel is also range. So next, in the clustering process, here zigzag raster diagonal approach are proposed. Zigzag raster diagonal to analyze correlation in the image and strengthen the correlation in the resulting linear pixel sequence, which is easily exploitable for purpose of compression. A zigzag scanning pattern is such a method that is widely used in many compression techniques. In the image encryption, there are random permutation process also proposed. The technique involves three different phases in the encryption process. The first phase is image encryption, where the image is split into blocks and these blocks are permuted. Further permutation is applied based on the random number to strengthen the encryption. The second phase is the key generation phase, where the values used in the encryption process are used to build a key. The third phase is the identification process, which involves the numbering of shares that are generated from the secret image. These shares and the key are then transformed to the receiver. The receiver takes the help of the key to construct the secret image in the decryption process. The technique proposed is a unique one from the other in a way that the key is generated with valid information about the values used in the encryption process. Next, the encrypted images are going to compressed with the help of modified flood-filled algorithm and run-length encoding. In the modified flood-filled algorithm, this algorithm finds out that neighbor pixels can determine which belongs to some region as well as characteristics of pixel in the image. For compression, RLE requires linear input, which means progressing from one stage to another in a single series of steps or sequential input. Here considering 8 direction as well as rotated direction also. In the run length encoding, RLE is a very simple form of data compression in which runs of data are stored as a single data value and count rather than as the original run. This is most useful on data that contains many such runs. RLU works by reducing the physical size of the repeating strings of characters. This repeating string, called a run, is typically encoded into 2 bytes. Next, in the decompression part, the reversal process of the compression algorithm being proposed. Here also modified flood-filled algorithm and run-length encoding are reversed. Receiver divides B into L segments from 0 to L, that is k varies from 0 to L minus 1, each of which is associated with a cluster of prediction errors. For each BK, run length decoding can be applied. Next, in the decryption process, the reversal process of encryption algorithm is proposed. Here also the permutation and zigzag raster diagonal and also gap algorithm are applied. The receiver knows the secret key K. The corresponding permutation operation can be employed to get back to the original CK. With all the CK, the decoding of the pixel values can be performed in raster scan order. For each location, the associated error energy estimator and the predicted value can be calculated from the casual surroundings that have already been decoded. Finally, the result will be obtained, which is the related to the input image. So with PSNR will be estimated with the help of input image and also the obtained result. We discuss about the running procedure for our process. Select the main.m file in the current folder, right click that file and for executing this process. This is the main window for the CTC system designed for image using prediction error clustering and random permutation. By pressing the read image button, we can browse the input image from the dataset folder. Select any one images from the dataset folder. Here I display the input image in the axis 1 plot. By pressing the segment image button, we can perform the segmentation process by split out our input image into number of blocks. So here the segmented result of our image and also the pixel values for every block. Here I display only 10 blocks values, and by pressing the gap map algorithm we perform the gradient adjusted prediction and also mapping process. This is the gap map result for 10 blocks and this is the mapping result. Here I displayed for 10 blocks, and by pressing the cluster button we can perform the zigzag raster diagonal algorithm. Here, this is the cluster result for every blocks. Here I display the only 10 blocks. By pressing the permutation button we can perform the encryption algorithm with key generated, and this is the permutation result for 10 blocks, and this is the encrypted image result for every blocks, and here I combine the every block result into a single encrypted image. Now by pressing the compression button we can perform the modified flood fill and also the run length encoding process. This process will take some time for executing. This is the compressed output which I have displayed in the figure, and this is the compressed stream for each segmentation block. This is the compressed stream for first block, this is the compressed stream for second block, and as well as third and 10 blocks. Here I display the compressed image. By pressing the decompression button we can perform the decompressed result. It is reversal operation for the fill algorithm and also run-length encoding. This will also take some time for executing. This is the decompressed image, that is, we obtain the encrypted. Now by pressing the decryption button, we can perform the reversal operation of the encryption algorithm. Here raster diagonal and also gap map algorithm will be performed. This will also take us some time for executing. This is the decrypted image. This is related to the input image. Finally, by pressing the analysis button, we can perform the PSNR response between input image and also the obtained result. Finally, we design efficient image encryption then compression ETC system. Reasonably high level of security has been retained and it is proven by experimentally. Thank you.